Artificial intelligence is transforming the world. But behind every powerful AI system lies something most people rarely think about: a tiny piece of silicon. AI models may look like software, but the real engine of artificial intelligence is hardware. Specialized computer chips designed to perform trillions of calculations every second. And today, these chips have become one of the most strategically important technologies on Earth. Governments are competing for them. Technology companies are spending billions to acquire them, and global supply chains are being reshaped around them. Welcome to the AI chip war, a new technological competition that could define the future of artificial intelligence. To understand why AI chips have become so important, we need to look at how artificial intelligence actually works. Modern AI systems rely on a technique known as deep learning. Deep learning models analyze massive datasets to identify patterns. These patterns allow machines to recognize images, understand language, and even generate new content. But training these systems requires enormous computing power. Training a large AI model can involve processing billions or even trillions of mathematical operations. Traditional processors simply cannot handle this workload efficiently. This is where graphics processing units (GPUs) enter the picture. Originally designed for video games, GPUs are built to perform many calculations simultaneously. Instead of processing tasks one at a time, they process thousands of operations in parallel. This architecture makes them incredibly effective for AI workloads. Over the past decade, GPUs have become the backbone of modern artificial intelligence. Companies training AI models now build massive computing clusters filled with thousands of GPUs. Inside these facilities, racks of processors work together to train neural networks. These clusters require enormous amounts of electricity. They require advanced cooling systems, and they require the most advanced semiconductor technology available. At the center of this ecosystem is a company that few people outside the technology industry paid much attention to until recently: Nvidia. Founded in 1993, Nvidia originally focused on graphics processors for gaming. But over time, the company developed some of the most powerful parallel computing chips in the world. These chips turned out to be perfect for artificial intelligence. Today, Nvidia GPUs power many of the largest AI systems on Earth. Companies like OpenAI, Microsoft, Google, and Meta rely heavily on Nvidia hardware to train their models. Some AI clusters now contain tens of thousands of Nvidia GPUs working together. These machines represent some of the most powerful computing systems ever built. But designing AI chips is only one part of the story. Manufacturing them is even more complex. Modern semiconductor fabrication is one of the most advanced industrial processes in human history. Factories capable of producing leading-edge chips cost tens of billions of dollars to build. Inside these facilities, silicon wafers are processed through hundreds of extremely precise manufacturing steps. Each step requires specialized equipment. Each step must be performed with near-perfect accuracy. Even a microscopic defect can ruin an entire chip. Only a handful of companies on Earth are capable of producing the most advanced semiconductors. One of the most important is TSMC, the Taiwan Semiconductor Manufacturing Company. TSMC manufactures chips for many of the world's largest technology companies, including Nvidia, Apple, and AMD. Its factories are some of the most sophisticated manufacturing facilities ever constructed. But this concentration of manufacturing capability has created a major geopolitical issue. Most of the world's advanced chips are produced in a small number of facilities located in Taiwan. This means that global AI development depends on a fragile supply chain. Governments understand the importance of this technology. Artificial intelligence is expected to influence everything from economic productivity to military capability. As a result, semiconductor technology has become a strategic priority. In recent years, the United States has introduced export controls designed to restrict the sale of certain advanced AI chips to China. These restrictions are intended to slow China's ability to develop cutting-edge artificial intelligence systems. China, in response, has launched major investments in its domestic semiconductor industry. The country is attempting to build its own advanced chip manufacturing capabilities. But developing these technologies is extremely difficult. It requires decades of research, massive financial investment, and highly specialized engineering expertise. This is why some analysts describe the situation as a new technological arms race. But instead of missiles or nuclear weapons, the competition is focused on computing power. Artificial intelligence models become more powerful as they gain access to larger datasets and more computing resources. The more powerful the hardware, the more capable the AI systems that can be trained. This creates a powerful incentive for companies and governments to secure access to advanced chips. As demand for AI computing continues to grow, the semiconductor industry is expanding rapidly. New factories are being planned in the United States, Europe, and Asia. Technology companies are investing billions into AI infrastructure. And chip designers are racing to develop faster and more efficient processors. Nvidia continues to play a central role in this transformation. The company's GPUs remain the most widely used chips for AI training. But competition is increasing. Companies like AMD and Intel are developing their own AI-focused processors. Technology giants such as Google and Amazon are designing custom chips for their cloud platforms. These developments are reshaping the landscape of artificial intelligence infrastructure. But one thing remains clear. The future of artificial intelligence depends on hardware. Behind every AI model, behind every neural network, behind every machine learning breakthrough, there is a massive infrastructure of computing systems. And at the heart of that infrastructure are semiconductor chips. Tiny pieces of silicon that now carry enormous strategic importance. The AI revolution may appear to be about software, but the real battle is happening at a much deeper level. Inside semiconductor factories, inside data centers, inside the tiny processors performing trillions of calculations every second. The AI chip war has already begun, and the outcome of this technological competition may determine who leads the next era of global innovation.